Supplemental math videos from Circle Christian School.
Two-column proof with more geometry. Here's a few more examples of using a two-column proof with using the geometry. Example 1, we have been given that the measure of angle 1 equals the measure of angle 3, and we need to prove that the EBA is congruent to the DBC. Now, just a little side note here that when in geometry with proofs we're talking about measures being equal, then we do the equal sign, but when we're talking about shapes, we'll use the congruent sign. So, after we've had things drawn and taken a look at them, I like to actually see what we're trying to do, what we have. We know that we've got angle 1 and 3 here that are both congruent, and what we want to do is prove that angle EBA, this big angle, is equal to angle DBC. A little hard to see because it's kind of a small picture, but hopefully you can do that there, and we'll begin. Generally what you have are missing parts of what's going on in proofs here. So what we're going to do is just walk through the missing parts. Given that angle 1 equals measure of angle 3, that's the easy one. The first guy is always given, should be always able to do him. Next, we got to take a look at the information that we've been given, that the measure of angle EBA equals the measure of angle 3 and 2. And the reason why we can say that, you go back into your definitions or your postulates, and we know we can add angles, so this is the angle addition postulate. And you can shorten that up with angle add post. That's okay. Number 3, the measure of the angle from the last step is now equal to angle 1 and angle 2. And what you'll see here is what changed. That we took the angle 3 out and put an angle 1 in. Well, from the very first right here, we were given that the two are equal. Anytime you substitute anything equally, we just call it substitution. In number 4, we've kind of turned it around here, and what we have done is actually kind of changed these guys here. We've moved one for the other. And this is able to do, we go back again, we can add angles together. So we have an angle addition postulate. Look for the change from the one that you had before to the one that you have now. And here, what we've done is just substituted again. Now they'll call it transitive, but to me transitive means you had to move through one to get to another. I will call it substitution. You can call it either one. When replacing substitution, I will allow for it. Example 2 that are about some given line segments here. Just a note here that the measure of lines, when we're talking about the measure of lines, to having a little m in front of it, what we do is actually get rid of the little line up top, and that means we're talking about measure. So we're given that AC is equal to AB plus AB. And so you kind of identify, okay, here's AB, and if we take two of those, we'd put them together to make the long guy. So number 1, again, is the easy one. It's given. I like that. Next we have AB plus BC. Take your little finger up there. I wish you could see my little pencil. We'll have to work on that, having something that you have to follow here. That AB plus BC equals AC. And again, you go back into your postulates or your definition. We're adding segments. So this is the segment addition postulate. And I'll abbreviate that to segment add post. Yay. And we have AB plus AB equals AB plus BC. And the reason why we're able to say that is they're going to call it transitive again, but basically what we did is we replaced inside here, and I will call it substitution. And now again we're kind of replacing things. Or if you want to, if you take a look at this, let's see, we could take away, I'm going to go green. I can take away an AB here, use a little bit of that algebra and take away an AB. And this ends up canceling these guys out, and therefore we have AB equals BC. So instead of substitution, subtraction may be a better thing to say here. Example 3, we're given that M is the midpoint of segment AB, and sometimes we're given things without it being marked up, so what we have to do is our own marking up. Remember, what you do is you draw a picture, put down your given and your proof, and then start marking things up, label, 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 and I'm going to just kind of mark this up in such a way that, okay, he's the midpoint, and if he's midpoint, we remember some things from the midpoint definition, that it's right in the middle, so whatever it's cutting here cuts them in equal halves. Now I'm going to do these in green because we weren't really given that AM is congruent to MV, but I know it is because of what happened with the midpoint here, and we'll walk our way through. Okay, so M is midpoint. Number 1 is always the easy one, and it's given. And then we have AM is congruent to MB, and that will be those green lines that I put up there. Anytime you're not really given, but it is kind of given, you can pretty much assume that it's a definition of something. So I'm going to say definition of midpoint. Next thing is that we have AM equals MB, and you'll notice here what we did is we went from a shape, that's why it has the line up above it, to a measure. So the measure of AM equals the measure of MB, and that's just going to be the congruency theorem. So you can either call it theorem of congruency, or you can put measures are congruent, or you can just put congruent. Theorem 2.1 and Theorem 2.2 in the book basically say, hey, if you got two lines that are equal to each other, they're congruent. 2.2 says, hey, you have two angles that equal each other, they're congruent. So you can pretty much just say congruent. Number 4, AM plus MB equals AB. And that is our segment addition postulate. We can add segments together. AM plus AM equals AB. And from number 3, we know that AM equals MB. So what I did here was I just replaced something of equal value. And when you do that, it's substitution. Now doing the math, if I have one AM and another AM, it gives me two AMs. So that's a multiplication property. Two things being added together equal to multiplication. And then the last one, what caused the change here? Well, we divided out a 2, and we divided out a 2 here. So the division property allowed us to prove our last. Now, here's the thing. You really just have to give reasons for statements. If you're not sure about the reasons, totally go back and look at the proof itself. It will give you the reason. Look at the reason and go, oh, because we did this or we did that, or I see why they said that. Now, if you don't understand why it is, that's kind of the ones that you want to kind of star out. Why'd they do that? Why do that? And that's what we'll come back into class and talk about, or you can send me an email. I'll be happy to tell you pretty quick why something happened. It's a learning process to be able to be very exact in a proof. They are picky. You can't just go, hey, I was given and it happened. There are steps that happen. You've been doing it in algebra for a long time. Step 1, step 2, step 3 to be able to solve an algebraic equation. And that pretty much says is an algebraic way of proving that the answer is x equals whatever it is. Okay, you can always stop this, go back, take a look at it. Let me know what you think. Have a great day.